this machine hasn't run in decades. Today, one craftsman starts the long process of bringing it back. The first step of any true restoration is cutting through the decay. Rust expands as it consumes steel, creating deep pits that compromise structural integrity. Peeling back these compromised layers reveals exactly what the builder is up against. When a chassis sits exposed to the elements for years, threaded connections fuse into a solid mass. Salvage is no longer an option. Stripping the frame requires knowing which components to carefully preserve and which to sacrifice. An abrasive cutting disc makes short work of the seized brackets. The high-speed friction slices through hardened steel, instantly oxidizing the metal dust into a shower of bright sparks. Inside the crankcase, time turns lubrication into a liability. Decades-old engine oil breaks down into a thick, corrosive sludge. This heavy fluid traps moisture and microscopic metal shavings, destroying the very parts it was meant to protect. Draining it completely is the only way forward. The front suspensions carry the entire weight of the forward chassis during deceleration. Here, surface corrosion has aggressively attacked the outer tubes. Fork seals rely on a perfectly smooth metal surface to hold hydraulic pressure. Even microscopic pitting on these tubes can shred a new rubber seal in miles. This would lead to catastrophic fluid loss and a complete loss of dampening control. Every heavily oxidized component in this pile must be thoroughly inspected. The true scale of the restoration project is finally laid bare. A bare frame offers no place to hide. Stripped of its engine and bodywork, the backbone of the motorcycle is exposed to absolute scrutiny. Deep pitting at the critical stress points dictates the next phase of the build. Compromised sections cannot simply be painted over. They must be structurally rebuilt to handle the immense torsional forces of a running engine. With the heavy structural fabrication complete, attention shifts to the rolling chassis. Rubber compounds degrade rapidly under years of ultraviolet light. They lose their elasticity and harden into a rigid, brittle shell. Removing a decades-old tire is a grueling battle of leverage against vulcanized grip. The heavy metal rim must be carefully preserved during this extraction. Modern replacement rims rarely match the exact profile and weight of the original factory equipment. A few precise strikes from a hammer help break the rusted bond between the bead and the rim wall. Fuel tanks are notoriously vulnerable to unseen internal rot. Condensation forms inside empty reservoirs over the years, settling as water at the lowest points. This trapped moisture slowly eats through the thin sheet metal from the inside out. Prying away the external rusted tabs reveals the true extent of the damage. What initially looks like minor surface bubbling is often a complete failure of the steel barrier. A large section must be entirely cut away to prevent the oxidation from spreading. A fine metal mesh will serve as the foundation for a permanent structural patch. Cutting away the diseased metal leaves clean, unoxidized edges for a proper repair. A new steel patch is precisely fabricated to match the complex geometry of the reservoir. Arc welding on a hollow fuel tank requires masterful heat control. The builder must prevent warping the surrounding thin sheet metal. An intense electrical arc melts both the patch and the parent material into a single, unified liquid pool. As the weld rapidly cools, it contracts, forming a watertight bond that is often stronger than the original steel. Grinding the resulting seam flush removes the excess filler material. This critical step restores the smooth aerodynamic profile required for the eventual paintwork. The mechanical heart of the machine is locked beneath decades of hardened grind. Disassembling the top end exposes the internal combustion chamber where the most violent forces occur. Removing the ignition coil and carburetor strips away the external accessories. This leaves only the raw mechanical core. The cylinder head lifts away to finally reveal the piston. Heavy carbon buildup on the crown tells a clear story of its past life. Thousands of miles of unburnt fuel and microscopic oil leaks have baked onto the aluminum under intense heat. This thick layer of carbon drastically alters the engine's compression ratio. After hours of careful bodywork preparation, attention turns to splitting the main engine cases. Steel bolts threaded into aluminum housings frequently seize due to galvanic corrosion. Breaking them loose requires steady, even torque, to avoid snapping the hardened steel shafts deep inside the block. Prying the casing apart breaks the vacuum seal of the old hardened gaskets. This exposes the primary drive gears and internal bearings, all coated in degraded grease. Every internal seal has completely dried out over the decades and must be systematically replaced. Meanwhile, the bare metal frame receives its first critical barrier of protection. Primer is not just for color. It creates a micro-textured surface on a molecular level. This gives the final top coat layers something to physically bite into. It also permanently seals the raw steel away from atmospheric moisture. Halting the oxidation process instantly is the only way to guarantee longevity. A consistent, overlapping spray pattern ensures that the complex tubular geometry is completely encapsulated. True restoration often means fabricating entirely new mounting points when the factory originals have completely rotted away. A hardened drill bit cuts cleanly through the steel plate, clearing a precise path for new hardware. Rebuilding the internal clutch assembly requires carefully inspecting every compression spring for metal fatigue. A weakened spring will fail to apply enough pressure, causing the clutch plates to slip dangerously under heavy acceleration. Surface restoration is a calculated game of progressively finer abrasives. A high-speed rotary buffer strips away the heavily pitted aluminum layer on the wheel rim. This friction exposes the raw, unoxidized alloy beneath the damage. Bringing dull metal to a mirror shine actually seals the microscopic pores in the material. This makes the rim significantly more resistant to future staining and water damage. The prepped components are then coated in a durable primer, laying the foundation for a flawless silver finish. The chassis receives its final dark metallic coats, meticulously applied in multiple thin layers to prevent runs. This specialized automotive paint cures into a hard, durable enamel shell. It is engineered to resist highly corrosive impacts from leaking battery acid, dripping fuel, or road salt. Back on the bench, the aggressive teardown of the lower engine block continues. Rubber oil seals harden into brittle plastic over decades of intense thermal cycling. Prying them out is a mandatory step in any reliable engine build. A compromised seal will pull unfiltered dirt into the crankcase or hemorrhage vital oil onto the hot exhaust. Removing the main bearings requires significant mechanical force. Tight press fit tolerances have locked the steel races firmly into the aluminum housing for years. Every extracted piece of degraded rubber and scored steel is immediately discarded. This clears the board for modern, high-tolerance internal components. With the internal gears finally separated, the true deep cleaning phase begins. The raw cast aluminum of the engine block is inherently porous. It acts like a sponge, absorbing decades of baked-on sludge, oil, and atmospheric dirt. Mechanical scraping can only go so far before it risks permanently gouging the soft metal mating surfaces. Instead, the builder relies on complex chemistry to do the heavy lifting. The bare casings are completely submerged in a highly aggressive industrial solvent. This chemical compound breaks down the molecular bonds of the hydrocarbon chains. It safely liquefies the hardened grease without eating into the aluminum substrate. Vigorously scrubbing the casing forces the fluid deep into the narrow oil galleys and hidden crevices. Removing every microscopic particle of grit is not just an aesthetic choice. A single piece of leftover debris can circulate through the fresh oil and instantly destroy a brand new bearing. Before the engine cases can be reassembled, their exterior surfaces undergo a radical, labor-intensive transformation. What begins as dull, heavily oxidized cast aluminum is methodically sanded completely flat. The process starts with a coarse grit to knock down the high spots and rough casting flaws left over from the original factory manufacturing. Spraying water across the surface acts as a crucial liquid lubricant. It flushes away the suspended aluminum dust before it can pack into and clog the abrasive paper. Gradually stepping down to ultrafine grits systematically removes the microscopic scratches left by the previous sanding pass. Once the metal is completely smooth to the bare touch, a high-speed electric polisher takes over. Loaded with a dense cutting compound, the polishing wheel generates intense, localized heat. This slight thermal softening allows the abrasives to perfectly burnish the aluminum. The result is a flawless specular reflection that resembles liquid chrome. This mirror finish redefines the entire aesthetic of the motorcycle. Crucially, the ultra-smooth surface also prevents road grime and stray oil from easily adhering to the engine block in the future. The final visual identity of the machine is locked in at the nozzle of the paint gun. High-pressure air atomizes the metallic silver base, driving microscopic metal flakes evenly across the tubular frame. This silver foundation acts as a highly reflective canvas for the layers to come. Over the smooth bodywork, a deep, rich purple coat is carefully applied. The metallic flakes suspended beneath the purple layer catch the sunlight, creating a shifting depth that flat colors simply cannot replicate. Proper atomization ensures the final finish flows out into a smooth, glass-like shell. This seals the vulnerable sheet metal beneath a permanent layer of synthetic armor. With the casings gleaming, the delicate internal reassembly process finally begins. The heavy crankshaft drops perfectly into its brand-new main bearings. This massive rotating assembly dictates the entire mechanical rhythm of the engine. Its clearance tolerances must be absolutely exact to prevent catastrophic vibration. Fresh, unblemished gears are slid onto the spline shafts, locking the transmission assembly into place. Every steel bolt threaded back into the soft aluminum block is secured with precision torque. Assembling the clutch pack involves alternating smooth steel drive plates with highly abrasive friction discs. the heavy red coil springs provide the immense clamping force necessary to transfer rotational energy from the spinning crank to the transmission. A failure to seat these springs correctly would result in immediate power loss under heavy acceleration. A precision steel wrist pin connects the fresh aluminum piston to the connecting rod. Sliding the cylinder block over the piston requires compressing the delicate steel rings entirely by hand. These thin metallic rings are the only barrier separating violent combustion pressures from the lower crankcase oil. The heavy cylinder head drops down over the mounting studs, officially capping the combustion chamber. Securing the head bolts guarantees a perfect airtight seal against the new metallic head gasket. With the engine sealed, the focus shifts back to the rolling chassis. Fitting a stiff, unyielding rubber tire over a freshly painted rim is a high-stakes balancing act. The metal tire irons are wrapped in protective tape to prevent gouging the flawless purple finish. The thick rubber bead must be carefully stretched and seated deep into the center rim channel. Once inflated, immense outward pneumatic pressure locks the bead against the lip, preparing it to hold the massive weight of the machine. Back on the workbench, the intricate shifting mechanism is finalized. The small metal shift forks slide precisely along the grooved drum. This mechanism translates a simple tap of the foot pedal into a complex mechanical gear change. Sealing the side cover requires a fresh rubber gasket to prevent the highly pressurized internal oil from escaping. Finally, the external foot controls are mounted directly to the polished aluminum block. This critical hardware physically links the rider's inputs to the complex transmission spinning within. The final lockdown of the external engine casings relies on exact torque specifications. Over-tightening will crush the delicate gaskets, destroying the seal. Leaving a bolt slightly loose invites destructive harmonic vibrations to eventually shake the heavy assembly apart. The fuel tank is the visual centerpiece of any custom motorcycle build, demanding the absolute highest level of surface finishing. The final layers of automotive clear coat are laid down heavy and wet. This allows the atomized clear to flow out and self-level into a continuous glassy sheet over the purple base. However, even a masterfully sprayed finish retains microscopic surface imperfections. A fine soapy mist provides essential lubrication for the final wet sanding phase, safely cutting down any tiny dust nibs. Buffing the tank with a soft cloth and specialized polishing compounds slightly heats the clear coat. This friction forces the microscopic sanding scratches to flow out completely. This final mechanical process pulls an absolute mirror shine from the curved metal. It flawlessly amplifies the depth of the metallic flake trapped underneath. Precision mechanical timing is the difference between an engine that runs perfectly and one that instantly destroys itself. The internal gears align the vertical movement of the piston with the opening of the valves to the exact degree. Brand new ceramic spark plugs are threaded deeply into the cylinder head. The white ceramic acts as a high-voltage insulator, forcing the electrical current to jump the precise gap at the tip. This electrical arc is what ultimately ignites the highly compressed fuel. The fully restored carburetor acts as the mechanical lung of the machine. It uses the intense vacuum created by the falling piston to pull liquid fuel through tiny brass jets. This atomizes the raw gas into a highly combustible, invisible mist. When finally mounted to the polished block, the incredible transformation is complete. What was once a seized, oxidized lump of scrap is now a precision power plant. By the next morning, the build reaches its most critical milestone, the marriage of the powertrain and the chassis. Lowering a heavy, fully assembled engine into a freshly painted frame is an incredibly delicate operation. A single slip of the heavy block can instantly ruin hundreds of hours of flawless cosmetic work. Once bolted in tightly, the tubular frame essentially becomes a rigid, load-bearing extension of the engine itself. Vital fluids and electrical currents are carefully routed through the new veins of the motorcycle. The long, sweeping chrome exhaust pipe is bolted tightly against the hot cylinder head. An exhaust system is not merely a muffler. Its exact internal diameter dictates how efficiently the engine exhales burnt gases. This precise back pressure directly impacts the engine's entire torque curve. Up front, the vital steering controls are finally locked down onto the fork assembly. The wide stance of the handlebars provides the crucial mechanical leverage needed to countersteer the heavy machine at speed. Routing the flexible throttle cable creates the final organic connection between rider and machine. Inside the black protective housing, a braided steel wire links the grip directly to the carburetor slide. A simple twist of the wrist will soon dictate the rush of air and fuel into the combustion chamber. With all major mechanical systems successfully integrated, the machine is no longer just a collection of polished parts. It is a unified, capable vehicle waiting only for fuel, compression, and a spark. The true test of any intensive restoration is not how the machine looks under the bright lights of a warm garage. It is how the engineering performs against the brutal reality of the elements. Rolling out into the freezing air, the reborn motorcycle faces a beautiful but deeply hostile environment. Plunging temperatures make rubber stiffen and vital fluids thicken, instantly revealing any hidden weakness in the spark or fueling systems. The aggressive red tire chains bite deeply into the packed powder. This provides the essential mechanical grip that bare rubber could never find on hard-packed ice. Every internal component that was rusted solid just weeks ago is now functioning flawlessly under heavy, continuous load. The polished engine aggressively inhales the dense, freezing winter air. This oxygen-rich atmosphere naturally creates a far more powerful combustion cycle inside the cylinder. Meanwhile, the rebuilt front suspension absorbs the violent impacts of the uneven, frozen terrain. This keeps the chained tire firmly planted, translating horsepower directly into forward momentum. This deep winter ride is the ultimate payoff for every seized bolt drilled out and every grueling hour spent sanding. There is a very distinct satisfaction in pushing a vintage machine to its absolute limits after pulling it back from the edge of the scrap heap. It proves that the hundreds of hours of meticulous fabrication were never just about aesthetics. They were about restoring true, undeniable mechanical capability. The sharp contrast of the brilliant purple paint against the stark white landscape is a lasting testament to that effort. It highlights the sheer force of will required to completely reverse decades of quiet neglect. What was once a rotting, seized pile of oxidized steel is a fully working machine again. It stands revived, incredibly resilient, and deeply honest about its own history. Every hidden structural weld they ground flat, and every internal bearing they seated is what its reliability now rests entirely upon. A machine built with this level of uncompromising care doesn't just survive the harsh winter environment. It commands it. Some things are simply worth the long, difficult road back to life. The restoration journey ends not under a cover in a museum, but out here, tearing through the quiet, frozen snow.